The next part of this unit is looking at transformations. When we have transformations, we have 4 specific things that we can do. The first one that we're going to look at is translations, but before we get into translations, I do want to talk a little bit about what a transformation is and what this thing called rigid motion is. When we have a transformation, that is an operation that maps an original figure called the pre-image onto a new figure called the image. So pre-image is the old one, image is the new one. When we look at the graph to the left, we have 2 different triangles. Triangle ABC is the pre-image, and then triangle A prime, B prime, C prime is the image. So that little dash in the corner is read as prime. And that's so we know that when we're looking at a graph, the difference between the pre-image and the image. When we have a transformation, it can change the position, the orientation, or the size of a figure. If we look at rigid motion is when a transformation preserves the size and shape of a figure. So we're not changing the angles at all or the sides. All of our corresponding sides and angles are congruent. The transformations that give us rigid motion are translations, reflections, and rotations. Again, with this video, we're just focusing on our translations. When we have a translation, that is a vertical and or horizontal slide or shift of a figure. If we look at the coordinate notation, so how we would write that out, we say that we have our pre-image point, x comma y, and that changes to x plus h and y plus k. In this case, h and k are just any number. When we say h represents our horizontal shift, so going along our x-axis. With k represents our vertical shift, going along our y-axis. H and k are allowed to be negative. It doesn't just have to be adding. If we look at example number 1, they gave us a rectangle and they gave us the 4 vertices of that rectangle, so our ordered pairs. Then they told us our notation, so they gave us the rule for our transformation. In this case, they said for every ordered pair that we have, we are going to change it by adding 5 to x and adding 7 to y. If I look at Q is -6, -1. Adding 5 to -6 gives us -1, and adding 7 to -1 gives us +6. We're going to do that same exact rule to the 3 other points for our image. On the graph, you can see that I've already graphed our pre-image, so the rectangle QRST, and then I've also graphed our pre-image, or our image, excuse me. We can always double check by counting over and up to make sure that we are in fact going over 5 and up 7. Number 2, we have a triangle. So they gave us triangle CDE with all its vertices, and they told us our rule is subtracting 3 from our x and adding 8 to our y. Looking at C, we are subtracting 3 from 2, and we are adding 8 to -1 to get us a new point of -1, 7. So that is the new point for our image. We're doing the same thing to E and to D. And again, the image and the pre-image have been graphed. 3 and 4 are the same way. So they gave us our original points for our pre-image, and they gave us our rule. In this case, we are adding 2 to our x and subtracting 2 to our y for our rhombus. When we do that, we get our new points for our image. I do want you to notice that it doesn't have to be a big shift. In this case, our image and our pre-image are overlapping each other, and that's okay. It doesn't have to be an entirely different position. When we look at number 4, they gave us a square, and then they gave us our rule. For our rule this time, they did tell us that we're subtracting 7 from our x, but they didn't tell us any change for our y. That means y is staying the exact same, and all we have to do is subtract 7 from each of our x values to get those new points. So doing that, we find our new ordered pairs for our image. And then again, we can graph the pre-image and the image. That's one type of problem that we can do with translations. The other kind is they can give us our graph of our pre-image and our image, and they can ask us to write our rule. When we write our rule, the easiest way is to pick one point and count your horizontal and your vertical shift. If we look at point D, I'm going to count how much I'm going to the right and how much I'm going up. So going to the right is 1, 2, 3, 4, 5, 6, 7. So that means I'm going right 7, and I'm going up 1, 2, 3, 4. When I write that out as my rule, I'm going to say x comma y for our ordered pair. The arrow means I'm changing it to my translation. So I'm adding 7 since I'm going to the right, and I'm adding 4 since I'm going up. 16 is the same thing. We have to make sure we start at the pre-image and then count to our image. In this case, our pre-image is down below. I'm going to count from point P. I'm going to go left 1, 2, 3, 4, and I'm going to go up 1, 2. Since we're going left, that would be subtracting 4, and up is still adding 2. If I were to go down, then I would subtract 2. But those are the two different types of problems that we can do when we're doing translations for our transformations.